In this demo, I just want to quickly go over this exercise, and the first thing I want to talk about is taking dimensions. So if you go to the drafting toolbar, you will see you have linear dimensions, and within the same panel you also have the radial dimension. So if you click here, you can take dimensions of your circles. In this case, I created one circle that is 3 units and the other that is 6 units. So this is how I would suggest that you start this drafting, because typically when you don't know where an object is placed, you should start with whatever is given. So the size of this radii is given, the size of the inner radii is given. So we know we have 3 units and 6 units, but we don't know where they are placed. So when the placement of an object is not given, typically it means you can place it however you want. Now there is a few hints on the placement or the orientation of where these are supposed to be, and one of these is this indication for the 4-inch. So the center point for the arc that goes out of the 3 and 6-inch circles will have a center point here. So we already know that. Now, one of the problems with this is, depending on your object snaps, it's very difficult to snap. So again, this is not the easiest way to do this. Now, something that you could do is use the line command. So you can go up here with your lines and you can use a single line and then change the options, or you can simply use the perpendicular from curve. Instead of clicking on this option, I will go and use the same option from the single line and just click on perpendicular. So this is the same command. Yeah, it's a perpendicular line. And here we have a few options. For now, I don't have to worry about it. I can simply click on this circle and click on the endpoint. And so now we know that if we created a circle from here to there, we would have correct proportions between this circle and the next. So this is one way to do it. Now the problem that's going to happen here is, if we move this in, we don't know where to stop, so it's not that easy. There is a trick to get a good approximation for where this would go, and the trick is to use a line. So we can use a polyline or a regular line, single line. You can also type in line and press enter. Now let's go up here and use the intersection, the endpoint, and that's it. Okay, so we can use int up here and there, and then if you use a line that goes from here to there with the midpoint, and if you move this line or if you scale it, you should be able to get this. So basically what this gives me is it gives me a reference of where it should intersect. It should intersect around this point. Now it might not be exact. Let's make sure we use Smart Track and let's check if it works. Honestly, I don't think this should work. So let's go in, trim this so we have an endpoint, and let's try it out anyway just to see if it gets us close. And it seems like in this case it got us very close, but as usual, as I thought, it's not exactly there. So this is why you would want to use the other option. Let's go back, let's undo this, and let's try the option called, and let's go back here. This was a question, so I need to make sure I answer this question about what TTR stands for. So this is what it stands for. It stands for this option under curve, arc, and when you use an arc, you have all of these options. And one of them is called tangent, tangent, radius. So this is what TTR stands for. It's for the first letter of tangent, tangent, and radius. So if I click here, I can create a tangent from this curve, and then a tangent from this curve, and then we can define the radius, and we don't know what the radius is, but we know it will be greater than 1. So let's do 1.5. Press enter, and here again we get something that's just, it's not what we want. So this is where this technique will come in handy, because by using this technique we can approximate where this should be based on our design. We can move it in place, and now we can figure out the radii, which we already defined here. It's 2 units, I believe, and we can double check that. We can go under drafting, dimension, the radial dimension, and in this case it says it is actually 1.1. So if it is 1.1, we can simply use the same technique we used before. Under curve, arc, tangent, tangent, radius, click here, click there, define the radius of 1.1, press enter, and click. So this is one way to do it. This is a little more precise than that, or at least it has a better tangency. You can get it even closer by changing the number, or if you want a more precise number, you can also type in a radius. And so if you select a circle and you type in a radius, it will give you the exact size of the radius, which in this case is 1.104. So if you want more precision, you can use this command. If you're not sure where to find the radius command, let's look at it. Radius, where can it be found? Under Analyze. So if you go to the Analyze menu, here you have a radius, and you also have a length, you have a distance, the angle. So these are useful, but at the same time they don't give you a graphic indication of a measurement. So sometimes they're really useful, such as in this case, it's very useful. Sometimes it is not. So again, the number we want to use is 1.104. So let's delete this, delete that. Okay. Use the same setting. Curve, we're looking for the arc, the tangent, tangent radius. From here to there, 1.104. And click. And now if you look at the center point, the center point should be almost exactly where it needs to be. It's very close. So again, you know, it's not exact, but if you look at this is also lacking some precision. So this is what I would do, you know, use the dimensions that are given, practice using the tangent radius, and hopefully you can get something that looks good. Now I went and I made it very, very precise, but you could have made a simple circle at 1 inch or 1 unit, and that would have been fine. I just wanted to show you exactly how you would get it as close as possible to a precise tangent circle that has a center that matches the 4 unit dimension. So it is technically not exactly 4 inches. In fact, if I delete this and if I check the dimension from the center to this center, and let's use Analyze, length, you will see it is 3.799. So my dimension is off by basically 0.2. Yeah, 0.2 units. So it's not very precise, but I think you get the idea. So this is how you would create these details which are not specified. And again, you know, the reason why they're not specified is for you to play around without being too concerned about these dimensions. So start with what is defined and then play around with the commands that we just talked about.